All right. Hey everyone. I'm QEDK. I work at Avail, which is we're aiming to be the unification layer for Web3. And today we sort of want to present an idea, which is essentially to say that can we really focus on fixing interop in a world of thousand rollups, right? Because if you look at Ethereum today, if you look at parachains, if you look at any X other ecosystem, we're going to see there's a lot of liquidity fragmentation, right? So before we get started, just to clarify again, I work in the R&D team at Avail. Essentially, what we're working on is to build new products that sort of work for the masses, trust optimized products, trust minimized products that we can actively have users use such that they actually have a seamless experience in Web3. So before we start off, maybe we talk a little bit about what do we have today, right? The status quo today is unfortunately quite fragmented, which means that if today, let's say you're on base and then you really want to go to another different chain like Arbitrum, or even if you want to cross parachains, the solutions that you have are much more different than you would expect in a Web2 like experience, right? And I think we can observe this if you go to a site like L2Beat or the bridge version of L2Beat, where you have probably 50 to 100 rollups and a similar number for bridges as well. And a lot of these chains and bridges also have like a sufficient amount of TVL, right? It's like multi-billion amount of TVL. For example, like Arbitrum today has 13.04 billion, which is like crazy for one particular rollup to have, right? Where you're actually rivaling other L1s that sort of exist today. And what this effectively means is that the cross-chain experience for an average user is effectively terrible, right? It's insane, right? And so just to kind of kick it off, what we will discuss is how does the average experience today look for a particular user, right? And this is when we come to typical cross-chain bridging experiences. So let's say that you are on some particular optimism chain, or you're on some particular Arbitrum chain, and all you really want is to have your USDC on optimism be USDC on Arbitrum, right? It's a really simple ask. But effectively, what that boils down to today is a four-step process where you're locking some particular assets on Optimism, and you will essentially have those similar assets, but a different version of those assets because these are L2 assets that are minted on Arbitrum. And then let's say you want to kind of have it back on Optimism. Let's say you have used the DeFi on Arbitrum, you have kind of gained your yield, and then you want to off ramp from Optimism. You'd be burning those USDC assets, and actually then is when you'll get the original version of the USDC, the one that you can actually off ramp back on Optimism. And I think the overall gist is that it's really conflicting. And let's say you're using Venmo, you're using Zelle, you're not really understanding how this works, right? Like, why are there two different versions of USDC? Why do I have to do four transactions? It's not something that makes sense natively to someone who's not in this industry. And that is something we actively need to kind of fix and work towards, right? So if we imagine how it works in Web2 today, effectively you go to Amazon.com, you pick your favorite video game or your favorite sofa cushion, and then you're like, yeah, I'm just gonna pay this with my PayPal. Like, I'm just gonna put my Amex or Visa in, and then effectively what is happening is PayPal is settling it with Visa in the background, and then you don't really care, and then you're getting your cushion in a day or two. And this experience needs to be replicated in Web3 is kind of the point of the talk I'm giving today, right? So now what we'll kind of pivot to is to talk about an ideal world, right? What can Web2 be like, in fact, today or even 6 months from now, that can actually make a user feel much, much more at home, where everything feels like Venmo and Zelle and not like something her mom can't use, right? So today, let's consider two highly specialized chains. We have an NFT marketplace chain that is only tracking NFT ownership, right? Think of this as an OpenSea chain, for example, or a Blur chain, right? All it is doing is storing NFTs for everyone in the world, right? You can even think of this as a Starbucks reward program that is on chain. And then similarly, you have a payment chain which is only tracking account balances, right? Think of this as your bank, think of this as your card that is actually used to pay for things and get things done. And with this paradigm, what we are saying is in this ideal world, you go to your OpenSea chain or your Blur chain, and then you just make a trade, right? You see this very cool BAYC or MAYC, whatever you're into, and then you're like, this is what I want. I want to really pay 100 ETH for this. Why should you? I don't know, but that's what you want. right? And for you, it should be as simple as you go, you click to buy it, and you go to a payment provider, right? Think of this as you going to PayPal and signing in and saying approve, and then that's it. And this is the ideal world that we're trying to actively build at Avail in the form of a solution called Nexus. But let's delve into what that looks like, right? So after your payment is done, what that means is you go back to your marketplace and that particular BOIC you bought, you just get it and you have it for however long you want to keep it. And that is the typical e-commerce transaction that we want to replicate, right? Where it is effectively no dissimilar to the experience that you have today on Amazon, that you have on your car rental site or whatever e-commerce transactions that people are doing, right? And so I guess now the question should be like, how do we do it, right? Because while it's kind of very easy peasy to kind of just say, I mean, it's done, we're going to do it, we're going to do it in 16 to 24 months, it doesn't really mean anything unless you can execute, unless you can build a decent product that users actually want to use today. And this is kind of where we present the idea of Avail Nexus, right? What we kind of think of Avail Nexus can differ based on the security model you choose, but effectively the way you can think of it is it's a trust optimized roll-up interoperability solution, right? And let's say that you're a chain abstraction provider like Arcana or like the Socket team who are working on it as well. It's essentially a precursor to chain abstraction, which means that we want to make it happen for those partners who actually have the infra to build it out. And we want to give them the framework to build these solutions successfully. And that's where Avail Nexus comes in, or Avail, right? It's what we believe in, and that's kind of the goal of Avail as the Web3 unification layer. So the way to kind of think about Nexus today is it's essentially a permissionless interoperability protocol that allows rollups on EVM to sort of be unified by allowing communication at scale. Now, how do we do it? That's a tougher question. But effectively, the ways that we kind of want to tackle it is asynchronous composability, um, providing optimistic fast paths for short tail assets, validity proven slow paths for long tail assets, and ultimately what we want is a solution that is secured by Avail DA. Right. So there are multiple elements to Nexus, particularly three, and then we can kind of go a little bit into detail about the Nexus runtime as well. And the ZK Nexus layer, for example, today we'll have proof aggregation, which is also called proof composition, where you're sort of using recursion circuits to combine validity proofs across multiple rollups. We have a Nexus runtime that is embedded inside the Avail L1, so to say, that we're actively working on. And what that means is we really want to build open gardens here, right? I think for far too long, the EVM ecosystem and maybe even some of the Polkadot ecosystem, we have not really encouraged flourishing open gardens where people can opt in and opt out of. Right? This is kind of very much observable in the roll-up stacks of today, or even some of the RAS stacks of today, where people don't really encourage interop across stacks or interop across chains because they feel like they cannot extract enough value out of those particular set roll-ups. And that is something we want to actively fix, where we are saying, well, we are giving a choice. We have this ecosystem. Please opt in, please opt out. We don't really care, but we really want this service to be something that you want to use because it is that good. And then we can talk a little bit about what really secures rollups today, right? And effectively, there are two components that need to be verified, and the most crucial being data availability and execution, right? Execution today in EVM rollups typically occur in two forms. In general, for most chains which are not L1s, it will occur in two forms because you're settling on an L1 or an L2, or basically a layer above you, through fraud proofs or validity proofs, right? Fraud proofs typically today have a challenge window of 7 days, which means that the UX for withdrawals is quite not great unless you're using like an optimistic protocol like a cross or like a warden-based protocol like Wormhole, right? And this is alleviated in validity proofs because you can probably spend a bit more money, but you can actually have trust minimized chain security guarantees within 1 or 2 hours, depending on how expensive the L1 is. And similarly for the DA, like you have myriads of choices today. You have Avail, you have Celestia, you have EigenDA. Again, EigenDA is not DA layer, but that's a separate question. And what this effectively boils down to is that without DA guarantees, rollups are not secure because either the safety or the liveness property of a rollup has to be invalidated, right? That's typically how rollups work today. So if we talk about a normal cross-chain interop experience today, whether it be across, whether it be wormhole, it doesn't really matter what it is. Effectively, what it boils down to is that you have n number of chains, and then you have to run some sort of a client for them, such that you know the exact state route, and then you can actually validate orders. You can actually validate messaging between those said layers, right? Where you have, let's say, you want to interrupt from optimism to base, you'll have LCs, you will have full nodes that are actually actively validating the state of the chain. And this, what this also means is that the cost of sort of going across these chains increases linearly, right? So if you're a solver, if you're providing solver infra, and then you have you're on three chains, the cost of the nodes is going to increase linearly and even super linearly depending on how you do it, right? And this is not great. This is not a great experience, and this is something that we can actually fix using zk nexus. And what we are saying is that you can imagine a nexus adapter that lives with each zk chain, right? Because again, this is typically, we want to provide a trust minimized experience in zk nexus. So what this means is, if you're a zk sync era or you're a cdk chain, you effectively run an avail lc, you have an adapter. The adapter converts your settlement proofs into something that is readable inside the Nexus runtime. And you can seamlessly interrupt just by updating your state root and having the Nexus runtime or the verifier that lives inside the Nexus runtime validate your particular state roots. And with those trust minimized guarantees, we can actually interrupt between, let's say, any validity proven chain. While this means that the latencies are higher, this means that the cost for a solver, the cost for someone who wants to do messaging is much, much lower, because these proofs are all composed together singularly. So the costs are, to be fair, sublinear, which means that instead of like the superlinear cost that you would have in the case of solvers running full nodes for every chain, you effectively just need to monitor Nexus and the particular chain that you're interrupting to and from, right? So the costs are much, much lower, because we can aggregate all of these proofs at the same time. And this also means like the cycle count would be much lower than what it would be if they were done separately. And a good example of this would be contingent execution via zk nexus. And again, this is something that is only possible using validity proofs, because what this effectively boils down to is that if you make a transaction on the particular NFT chain, you can know for sure that whatever state update takes place on the payment chain has to be guaranteed, because otherwise it would not be valid, right? So if we go through this particular flow diagram that we have here, we have, let's say, you, the user, kind of reserve the NFT on the OpenSea chain. You make the payment on the payment chain. You essentially check for the payment inclusion in Nexus, and that's through the Nexus adapter. You check for the payment inclusion, non-inclusion, which is effectively just a storage proof along with a validity proof that is posted from Nexus to the NFT chain. And then based on that, you can know whether you want to cancel or confirm the NFT transfer, right? If you can prove the inclusion of the payment, then you obviously give them the NFT. And then if you can prove the non-inclusion, you do not give them the NFT. And it is as simple as that. And this is sort of only one aspect of what Nexus is, because these type of flows typically have higher latencies, because the cost of proof generation is sufficiently high, which means that we need solutions that work in ultra low latency situations as well, right? So the question is, why zk Nexus? And the primary reason is that if you want to bootstrap liquidity today, it is unreasonably hard for rollups, right? If you are making a rollup today, if you're making a parachain today, the cost of getting liquidity on your chain is close to impossible, right? Either you're burning through your treasury or you're burning through your raise just to kind of get liquidity on a rollup, which makes no sense, because theoretically there is a lot of liquidity on other rollups that is just lying there that is not being used, right? And effectively, what we can provide through zk Nexus is essentially trust minimized guarantees through validity proofs, efficient but slow interop, which means that you don't need to run full nodes of every chain. The latencies are slow, but it works. And what this particularly means is that for long tail assets or assets that are typically illiquid, which means like one-sided liquidity where you just have a token of your treasury, you can actually use the messaging layer and you can actually transfer assets at scale from one chain to another. And that's what zk Nexus solves today, right? And for the last bit, what we're going to talk about is something that is quite new. We're calling it OP Nexus, essentially representing optimistic Nexus, which is a version of Nexus that really works for ultra low latency systems, which can be even as short as 500 milliseconds to maybe a couple of seconds. Where what we're saying is you make an order intent on a particular chain. And then the intent gets expressed to the rollup settler. You send the proof of intent to the rollup contract one, and then we have a Nexus settler contract. This is for the OP Nexus, which is part of the Nexus runtime, and the Nexus runtime effectively lives along with the DA on the Avail L1. And every time that the state root is updated, it is also updated in Nexus settler, right? Which means that any other system that has opted in to this particular OP Nexus runtime, they can actually access the state roots of other chains, and we can actively use this for interop, right? So there are multiple elements to this. I think one thing you can look at is the ERC20 bridge order, where you can sort of see what can an intent be expressed like. It typically has the normal things, which is going to be your source, destination, how much amount you're going to give to the solver, how much amount you want back from the solver, who can resolve your disputes on L1, how much insurance you want to pay, and the nonce, right? And effectively, what we want is a complete intent that is able to be expressed such that when it is filled on a different chain, or even if disputes occur, we can actually resolve it effectively in a manner that the user has agreed to, right? So again, just to kind of complete the flow here, on rollup 2, effectively, you have a solver that observes that this intent has been made, that reads the state from the rollup settler, and it fills, which basically means that the assets are sent to the recipient that has been designated in the original intent. And this again goes to the rollup 2 contract, which is then read by the Nexus settler, which means that with the particular storage proof that the order was actually filled, they can send it back on the original rollup 1 to the rollup settler, and for which they have to give a storage proof, and they have to give the filler data saying, well, this is done, and they can actually claim the funds that were held in escrow, right? The cool aspect of this would be that we're actually able to provide crypto economic guarantees. So what we're effectively saying is that if you're able to prove as a watchdog or as an external actor that a particular state root had a fill, and then the chain rolled back, and the particular state root doesn't have the fill anymore, we can know for sure that the fill doesn't exist anymore, which means that the user needs to be compensated. And then you can see we have a small element here, which is straight root solver. And that's kind of the contract that is responsible for doing that, which is determining that a particular rollback has occurred and that the user should get the insurance payout, right? But also, apart from this, what we are saying is you don't need straight root resolver. You can use human resolvers here like UMA. You can use AVS resolvers here like Symbiotic, and they can kind of provide other guarantees, and that the user should have the freedom to choose, or an app chain dev that is using this like Across or Everclear should have the opportunity to kind of choose and pick that particular model. And again, this is a simple rundown of OpenAccess because I don't want to delve into too much detail. But I guess the last question to answer here is, why do we need OpenAccess, or why should we have OpenAccess? And that is because we believe that app devs and users should have complete flexibility when they are deciding on what they want to build, right? This particularly means that you get to bring your own security model, right? You can write your own resolver, you can pick a symbiotic resolver, you can pick a multisig for all you want, right? And what this means is that we also have an optimized trust boundary, such that when you have a rollup that trusts another rollup, the latencies between those said rollups, the interop speed should be much, much lower than that is typically possible. And what we kind of want to solve for is reasonably fast interop, which basically, as we are kind of translating it down today, is going to be a couple of seconds. And we are also building with open standards like ERC7683, such that if tomorrow, let's say, Across wants to use it or Uniswap wants to use it, they actively can. And all of this is going to be open sourced as well. And so at Avail, as you know, our goal has always been to sort of make modular chains unified, right? Because the modular thesis is effectively that you have the roll-up components like execution, consensus, DA. As a user, you should have the choice to kind of decide what your VM will be. You can decide what your consensus algorithm will be. You can decide where your DA will be. And the idea is that with our suite of solutions like DA, Fusion, and Nexus, this can boil down to running an Avail LC, and where you have an n number of modular chains that are able to interop just by running an Avail LC and opting into Fusion and Nexus. Again, Fusion is sort of just to provide other shared security guarantees, but just with DA and Nexus, we can provide much more similar guarantees and much more unified experiences because you have the opportunity to use OP Nexus or ZK Nexus depending on what kind of assets you want to support and what kind of chain liquidity that you have. And so when we talk about that Amazon-like experience where you're just checking out your sofa cushion or your video game, it's as simple as you paying on PayPal and then being settling in the background, and you really don't need to worry about anything else. And that's what we will enable with Avail to Web3, right? Where you're checking out on Optimism, you're going to and then you just want to buy your BAYC, where the transaction gets processed on Avail, and you pay on Polygon, and then that's it. You get your NFT on Optimism, right? And that sort of experience like Venmo is sort of what we want to bring to Web3. And with that, that's all we have for today. This was Avail. Let's unify blockchains.
I've forgotten my question in the shenanigans. Do chains that want, like you mentioned, OpenSea on Optimism, do they need to be using Avail DA in order to make use of the Nexus?
So that's a good question. The answer is it depends. So for example, if you want to opt into ZK Nexus, then technically you need to have a verifier that is enshrined in Nexus. So for that particularly, you don't need to use Avail DA, but you do need to use the Nexus runtime of Avail. And then consequently, we have OpenNexus, for example, which is actually just an open source suite of, it's like a framework for which you don't need any opt-in at all. You don't even need Avail, and you can actually get it working on any Avail chain, so to say.
Yeah. You said at the end there, on any Avail chain. So by running a Avail-like client, that's what makes you an Avail chain?
I mean, sure, because if you're running an Avail light client, it means that you have DA on Avail. But when I say Avail chain, technically there are two different perspectives to it. One would be, are you posting data to Avail? That is one. And second is sort of the new version of Avail chains that will come up that are based on Avail, that is, they're enshrined in the Avail L1. So two different ways to think about it.
What kind of timelines are you guys thinking for deployment for this interop?
So for ZK Nexus, we have a DevNet already, which we had back in December, at the end of December. For OpenNexus also, we don't really have a DevNet. Technically, it's in progress, but we have a demo for the DevNet. We are just working on setting it up. And maybe we're thinking 6 months down the line, we will get closer to it. Also because with ZK Nexus, bottleneck is going to be like the ZK VM performance itself. And while the speed of execution is sort of improving rapidly, real-time proving is sort of still a bit far off. By real-time proving, I mean, can you prove an Ethereum block within the Ethereum block time? Which is still a bit far off. Maybe at the end of the year, we'll get closer to that. That's sort of the ideal number when we kind of start to see this becoming much more seamless. But if today you want to sort of interop using ZK Nexus and you have a lot of chains, it's probably going to be an hour or 2 hours. And again, like that's for our long tail assets, right, which don't really have price fluctuations or they have low liquidity. So for those actually is why we have built OP Nexus, where there are other solutions available that you can actually use, which is in the form of OP Nexus. All right, that's it. Again, great to be here. I'm QEDK. Thanks for listening.